So continuing from where we stop, organic chemistry. So the next topic is classification of organic compounds. So we want to classify all the organic compounds. The first class, we call it alkane. 2, we have alkene. 3, we have alkyne. 4, we have alkanol or alcohol. We have 5, we have alkanoic acid, alkanoic or carboxylic acid. We have 6, we have alkana or aldehyde. We have 7, we have alkanol or acetone. We have 8, we have ALKANES or ester. ALKANES or ester. We have ether. We have 10, we have nitride. We have nitride. We have amine. We have amide. We have amide. We have amide. We have fat and oil. We have protein. We have protein. And finally, we have carbohydrates. These are different classes of organic compounds we have. So we are going to represent this in a tabular form. So it will look like this. Let's say we have the class here. We have the class here. You have the functional group here. We have a number of carbon atoms. We have number of carbon atoms here. We have the prefix. We have the suffix here, in the beginning and the end. So the first member, we call it we have alkane, we have alkene, we have alkyne, we have alkanol, we have alkanoic acid, we have alkana, we have alkanon, we have ALKANES, we have ether, we have amine, we have amide, we have amine, amide, we have nitride, we have protein, we have fat and oil, and finally we have carbohydrate. They should be 15 in number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's see the functional group here. The functional group is C single bond C, C double bond C, C triple bond C, COH. Alkanic acid C triple bond, double bond OH. ALKANES C double bond H. ALKANOL R C double bond R. ALKANES R C double bond OR. IUPAC ROR. Amine RNH2. Amide RCONH2. Nitride RC triple bond N. RC triple bond N. Okay, this one, no specific for now. We shall look into this. Protein, fat, and carbohydrates. If the number of carbon atoms, you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on. Previous, if the number of carbon atoms start with 1, so throughout organic we call it met. Met means 1. 2 is earth. 3 is prop. 4 boots. 5 pants. 6 X. 7 het. Hate. Hot. 9 none. 10 out. 11 mono. 1 plus 10 mono. No, 10 is deck. So mono deck or unideck. Mono or unideck. Dideck or duodeck. Call it dideck. This one is a trideck. This one is tetradeck. Tetradeck. This one is a pentadeck. This one is hexadeck. This one is heptadeck. Heptadeck. This one is a octadeck. This one is a nonadeck. This one is equals. 20 is known as equals. 20 is known as equals. So the suffix is it's supposed to be X suffix. If for this group it must end with ANE for alkane. So alkane with carbon atom we mentioned we call methane. If it is 2 carbon atoms we call methane. If it is 3 carbon atoms we call propane. If it is 4 carbon atoms we call butane. Like alkane, 2 carbon atoms be ethane. This one will end with E. This one will end with ENE. This one will end with YNE. This one will end with anol. If it is methanol, propanol, butanol, pentanol, hexanol. This one will end with anoic acid. Anoic acid. This one will end with ana, metana, alkana. This one will end with anol. Anol. This one will end with YL methyl methanate. The amines. This one will end with ether. Okay. Amines. This one will end with YL with And this one will end with Li-ether. So we can have methyl-ether, dimethyl-ether, or ethoxymethane. This one will end with amine. This one will end with amide. This one will end with nitride. So it can be ethanonitride, and so on and so forth, like that. So this will be the prefix, this will be the suffix. As you are naming it, you will understand it better. So this is the table. IUPAC nomenclature, the functional group. What do you mean by functional group? Before IUPAC nomenclature, functional group. Let's see the meaning of functional group. The meaning of functional group. This is a group of atoms or radicals with a distinctive chemical property. Regardless of atoms of other elements in a molecule. Many functional group is a group that determines the type of chemical reaction an organic compound will undergo. So that's the meaning of functional group. So let's see one by one. Let's see alkane. We want to see the functional group in alkane. So the functional group in alkane is C single bond C. That's the functional group. So 2, we want to see functional group in alkane. Is C single double bond C. That is the functional group in alkane. 3, alkyne. The functional group in alkyne is C triple bond C. 4, we want to see the functional group in alkanol. Is COH. That's the functional group in alkanol. We want to see the functional group in alkanoic acid. Alkanoic acid or carboxylic acid. This one is a C triple bond double bond OH. We want to see functional group in alkana or aldehyde. Alkana, C double bond A single bond H. We want to see functional group in alkanol. Alkanol. We have RC, have double bond here. So in WAHEC, this is regarded as R2CO. Please take note of that. It's either this or we say R2, then how many C? C1, then CO. Then we have ether. Ether is written as ROR, which can be written as R2O. R2O. We have ALKANES. ALKANES is written as RC double bond OR, which is written as RCO2. That's the functional group in ALKANES. We have seen functional group in ALKANES. Functional group in amine, is written as RLH2. 11, we have amide. The functional group is RCONH2. While finally the functional group in nitride is RC triple bond N. These are examples of functional groups in different organic compounds. So the next thing is IUPAC nomenclature. IUPAC nomenclature. IUPAC nomenclature. IUPAC nomenclature. The word IUPAC means International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Why nomenclature altogether? It means this is the system. This is the system of naming organic compounds. Here we are dealing with organic compounds. This is the system of naming organic compounds. This is the system of naming organic compounds. So we start first of all with alkanes. How do we name alkanes? Alkanes. Remember the functional group C single bond C. We want to start with alkane. How do we name alkanes? The general formula of alkane, of all alkanes, is CnA2n plus 2, where n is equal to number of carbon atoms. So n is equal to number of carbon atoms. N is equal to number of carbon atoms. Number of alkane. First member of alkanes is methane. Remember, met means one, then ane is the suffix. So methane, meaning it has one carbon atom, n is equal to 1. So the formula for methane, the molecular formula of methane will be Cn. Remember the formula, CnA2n plus 2. So put 1 here to be C1, H2 times 1 plus 2. So to be CH2 times 1 plus 2, CH4. And structurally, it is written as H here, H here, H here, H here. So this is the structure of methane. So that's the name methane. So the first member of alkane is methane. So the second member, we call it ethane. X name 2. So ethane. So it will be C2, apply the formula, A2 times 2, 4, 2, 6. The carbon, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen. So that is ethane. 3. We have, that is C3H8. Structurally, it will be hydrogen here, 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 hydrogen. So this is propane. Let's see butane. But means 4. So C4H10. It will be 1, 2, 3, 4. Complete it with hydrogen. Complete it with hydrogen. Complete it with hydrogen. Complete it with hydrogen. That is butane. That is butane. Chapter 1. Let's see question. Write down the molecular formula. The molecular formula of the following members of alkane group. Following members of alkane group. So we have one. They say pentane. Pentane, you know, is pent is 5. Use the formula. Use the formula CnA2n plus 2. So it will be C5H 2 times 5, 10, 10 plus 2. That is 12. That's the formula. 2. Hexane. The formula is hexane. C6H14. 3. We have decane. Decmethane. That's C10H22. We have tridecane. Tridecane is 13. C13H28. And let's see icosane. Like I have said, icos is 20. So icosane will be C20H 2 times 20 plus 2. That is 42. This is the chemical formula for candle wax. Candle wax. That's the chemical formula for candle wax. We call it icosane, and so on and so forth. These are called straight chain. These are called straight chain alkanes. Straight chain, and they are straight chain alkanes. So we are going to look at branch chain. How do we name branch chain? But before then, let me say note. Take note of this. There are 3 formulas I've mentioned: molecular formula, structural formula, and empirical formula. So there are 3 types of formulae or formula. Namely, we have one. We have empirical formula. Empirical formula of organic compound. We have 2. We have molecular formula. And 3, we have structural formula. So we take it one by one with illustration. This is the simplest formula. This is the simplest formula of an organic compound or of a compound. This is the simplest formula showing the ratio of atoms of each element. The ratio of atoms of each element in a compound. Only show the ratio is the simplest formula. The ratio. See example. Example 1. You know the actual formula, molecular formula of the CC812O6. Once you factor 6 is common. See, this one will be A12, this one will be O, then bracket 6. You are taking 6 out. So the one inside the bracket, therefore the empirical formula is the one inside the bracket. The empirical formula of glucose. Because this one represents this glucose. So the empirical formula of glucose is Ca2 then O. That's the empirical formula. 2. Let's say you have something like ethane. The formula is C2H6. Now C2 is common. You take 2 out. This one remains 3, then bracket 2. So this Ca3 empirical formula of methane of ethane is Ca3. Please take note of that. Is Ca3. So that's why we generalize it by saying empirical empirical formula, that is generally, multiplied by N is equal to molecular formula. We give you the molecular formula. We are coming to that. That is the relation between empirical and molecular formula. So you have to factorize to get molecular empirical formula. 3. Let's see another thing. C4H8 This is known as a butane. We are coming to that. To write the empirical formula, you know, this can be written as CH. What is common? 4 is common. This one will be 2 bracket 4. So the empirical formula of butane is CH2, and so on and so forth, molecular formula, which is the actual. This is the actual formula. Showing let me use this is the true formula showing the actual number of atoms of each element in a compound. E.g., methane, which we have done, is equal to CH4. That's the real formula. Glucose, the real formula we have done, C6H12O6. Benzene, C6H6. These are the real formula. These are for molecular formula. That's the actual formula. But if benzene is now written as CH then bracket 6, so the one inside there is the empirical formula. You can see it shows the real, not the actual number. So please take note of that. That's molecular formula is the actual of a compound. That is molecular formula. And in organic chemistry here, it represents the general formula. So the general formula of an organic compound, it represents its molecular formula. We are going to look at the example on that. So let's see structural formula. This is the arrangements of atoms. This is the arrangement of atoms of each element in a compound. Based on its molecular formula. E.g., let's see methane. This is the molecular formula. So if you now draw the structure, so this is the structural formula. Please take note of that. So this represents the structural formula. This is the molecular formula. So let's see example 1 to show the difference between all these. Draw give the one molecular formula. Two, structural formula, molecular formula. Empirical formula. Three, structural formula and structural formula of, let me start with a thing of a thing of a thing. That is example one. Yeah? One, a thing. The molecular formula is using the formula CnA2n plus 2. That's the general formula. That is C4. When they say X means 2, C2, 2 times 2, 4, 4 times 2, 6. So that's the molecular formula. Roman figure 2, we have to find the empirical formula. So C2A6 factorized. What is common? 2 is common. This one remains 3. This one will be 2. So CA3, it represents the empirical formula. So the empirical formula of a thing is CA3. And finally, we have to find the structural formula. So 1, 2, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen. Let's see example 2. Example 2. The ratio of carbon, the ratio of carbon to hydrogen in a member of alkane is 1:3. Is 1:3. Is 1:3. Find the molecular formula of the alkane member. Name it. Name. So we start saying general formula. General formula. The general formula of alkane is CnA2n plus 2. So the number of carbon atom is n, the number of hydrogen atom is 2n plus 2. So we say n ratio 2n plus 2 is given to be 1:3. So n all over 2n plus 2 is equal to 1/3. Cross multiply. 3n is equal to 2n plus 2. 3n minus 2n is equal to 2. n9 is equal to 2. So we have gotten n to be 2. So the molecular formula will be C2A 2 times 2, 4 times 2, 6. So which is known as a thing. We have to name it. That is example 2. That is example 2. Example 3. Example 3. Example 3. Example 3. The relative molecular mass of alkane member is 58. The relative molecular mass of alkane member is 58. Find the member of alkane. Find the member. So we start by saying CnA2n plus 2 is equal to molecular formula, which is equal to relative is same thing as a relative molecular mass. Molecular mass of that member. So this is 12n. Carbon is 12, mass number 12. Hydrogen is 1 times 2, so it will be 2n plus 2. If you multiply by 1, that's what you have. Is equal to 58. Equal to 58. So 14n plus 2 is equal to 58. 14n is equal to 58 minus 2. 14n is equal to 56. N9 is equal to 56 divided by 14. N9 is equal to 4. So the name, the formula, the molecular formula will now be C4CnA2n plus 2. 2 times 4, 8, 8 plus that is 10. So this will be butane, and so on and so forth, and so on and so forth. Please take note of that. We have seen different examples. So let's see naming of branched chain alkanes. Branching alkanes. Naming of branching alkanes. There are rules guiding this. We have seen space chain. So naming of branching alkanes. We have steps or steps involved. First step, step 1. And the number of longest unbranched carbon atoms, and they write it as parent chain. That is step 1. Step 2, identify the functional group. Identify the functional group and write it as parent chain, as parent name. Write it as parent name. Step 3, identify the alkyl group. The alkyl group represented by capital R. Identify the alkyl group attached. Identify the alkyl group attached. Step 4, identify the carbon atom in which the alkyl group is attached. 5. Hands from left to right and right to left. Pick the smaller number. Step 6. Separate numbers from alphabets by using hyphen. By using hyphen. Separate two numbers by using comma. These are the rules. So let's see different examples. Example. Let's see one. 1, 2, 3. So this is a branched alkane. Let's count the longest. If I start from here, 1, 2, 3. The longest is 3. If I count from left to right, left to right is 3. Right to left is also 3. 1, 2, 3. If you count from here, 1, 2, 3. Count from here, 1, 2, 3. In any order, you see that the longest is 3. So the 3 is regarded as the parent chain. So the parent chain is 3, that is and any 3 is 4. So the functional group here is C double bond C. That's what you can see. So that is alkane group. So you end with alkane. So this is the family name. Parent name. So it's propane. 1, 2, 3 is propane. So in any order, if you count it from here, 1, 2, 3. This is what we call alkyl group, denoted by R. The T is a carbon. You count it from carbon 2, count it from here is carbon. So we say 2-methyl propane. We say this is methyl propane. 2-methyl propane. But take notes. Let me say notes. R, it represents alkyl group. With the general formula CN2M plus 1. It is a derivative of alkane when one hydrogen atom is replaced. When you remove one hydrogen atom. So the general formula is CNA2M plus 1. While that of alkane is CNA2M plus 2. So this is plus 1. This is the general formula of alkane. Alkyl group. This is what we call alkyl group. So the first member here will be, you put one is the methyl. So we have the methyl, that is a CA3. We have ethyl, that is C2H5. You can see it. You have propyl, C3A7, and butyl and etc. These are called alkyl group. So you can see CA3, that's why I call it a methyl ethyl. This is general purpose. So alkyl group generally are represented by capital R. polyalkyl group, and the general formula is CnA2n plus 1. It's a derivative of alkane. It's being derived from alkane when an hydrogen atom is removed from alkane, so we perform alkyl. So this is the first example, called it 2-methylpropane. So watch out for the next video, where we shall continue from where we stop. That is naming of branch chain alkane.